Bismillahirrahmanirrahim. Assalamu alaikum. In this unit, unit number 9, we are going to talk about the wastewater testing, treatment, and reuse. And why we do the testing of the wastewater in the lab, and if it is not good, then what are the methods to treat that wastewater to make it clean, and where we can use this water again, right? So this is the topic of this presentation. The first thing is that the what is wastewater? Any liquid discharge leaving residential unit, yani from ASCAN, commercial facilities like the colleges, hospitals, and other commercial facilities, institutes, industrial facilities, and after respective use is known as the wastewater. Once we use the water, it will become the wastewater. There are basically two types of the wastewater classification: domestic wastewater and industrial wastewater. Domestic is that which is coming from the mainly houses. Industrial is consists of the wastewater coming from the industrial setup and commercial setup, that is the industrial wastewater. Both type of wastewater having different characteristics. Generally, the domestic wastewater having the more organic component, like the food waste, kitchen waste, toilet waste, all this coming in the domestic wastewater. In the industrial wastewater, most of the chemicals are there which they are using in the industry. If we combine both of them, then it is known as the municipal wastewater. The combined domestic and industrial is the municipal wastewater. So this is the classification. When wastewater generated in these sources, it will go to the channel, wastewater channel, and then it will reach to the treatment plant. This is the wastewater treatment plant. The first, it will go to the bar rake screen. In the bar rake screen, generally the big solids will be removed, like the branches, stones, paper, plastics, bottles. It will be removed with this bar rake. These are the bars through which the wastewater will pass. Then in the next step, the grit will be removed. The grit is like small solid particles like the sand and the small stones, gravels, aggregates that can be removed in this tank. This is the grit removal tank. After that, it will go to the primary sedimentation tank. In the primary sedimentation tank or settling tank, this is the same thing actually. The two name for the same thing: settling tank and the sedimentation tank. Also, sometimes it is called as a clarifier. So here, what we do, this water will be kept in the tank. We will leave for few hours. Then most of the solid will settle down because of the gravity, and from the top we can take the more clear water. In the next step, up till here it is called the primary treatment, right? And from the next step it is called the secondary treatment. And the secondary treatment, which is generally is the biological treatment. In this, the wastewater is mixed in a big tank, just mix with the air, right? So what will happen, there are bacteria which are already present, they will grow in number, and what they do, these bacteria will eat the waste material as a food, and they will take the oxygen from the air and they will grow. So it means that all the waste material will be shifted from the water to the bacterial cell. So the bacterial cell will be grow and the waste will reduce. In the next step, what we'll do, we will put this in another clarifier or sedimentation tank where this heavy bacteria which are become bigger now, they will be settled, and from the top you can get more clean water. So this up till here it is called the secondary treatment. After that we will go for the tertiary treatment. The tertiary treatment, we do the disinfection because there are still some bacteria which are harmful for us. If you remember, those bacteria called as the pathogens. So these bacteria can be killed, can be removed by doing the disinfection. Disinfection can be done by adding the chlorine, by using the UV radiation, by using ozone. There are many methods. So after that, the water will become very clean. So now you can throw this wastewater into the river and any places, so it will not be harmful for anybody, or even you can reuse it for agriculture purposes like growing the crops, plants, and other thing. And from the bottom of these tanks, you see here some solids are settled here. Here also some solids are settled here. So these solids can be put in a tank which is called as a digester. So this solid from here and from here will go to a tank which is a closed tank where we heat little bit this tank. So it will create an anaerobic environment. Yani there is no oxygen. So the another type of the bacteria will grow and they will reduce the waste material. They eat that one and they produce the methane gas. This gas is useful for us for generation of the electricity or for getting as a fuel. We can use it, and the remaining solid we can use as fertilizer for putting in the agriculture and other places, or you can throw into the landfill or the incineration. So this is a complete setup of the wastewater treatment. Here you can see that we can use 100% of the wastewater and we can use the 100% of the solid also. So this is the zero waste production technique. The wastewater quality, when we check in the lab, generally we do some tests including the biological oxygen demand, chemical oxygen demand, total organic carbon, total solids, phosphorus, nitrogen. There are many things: metals, organics, oil and grease, pathogens like the bacteria and the viruses. Also we check the pH of the water, alkalinity. So by checking this parameter in the lab we can find out the whether the wastewater is good or bad for throwing into the environment or for reusing it. Let us talk in little bit detail some of the pollutant. The BOD, it is called the biological oxygen demand. Basically microorganisms, the bacteria are present in the wastewater always, and they decompose the organic pollutant. Decompose means they eat the waste material and break it, and this organic pollutant when they decompose it, they use oxygen, this bacteria. So they use oxygen for respiration and they use the waste material, organic pollutant, as a food, right? This is called the as aerobic condition. So this is the mechanism going on in a wastewater. The bacteria eating the waste material and using the oxygen. More food material they will eat, they will consume more oxygen. So the biochemical oxygen demand, or the BOD, is the amount of the oxygen needed by the bacteria to degrade the organic constituent. Degrade mean to eat or break the waste material to convert it into water and carbon dioxide. So these bacteria degrade the organic material, the waste material, right? The organic material, and they use some oxygen. So this amount of the oxygen which they use, it is called as the BOD. So indirectly, if there is more oxygen they will consume, it means that there is more waste material. So you can say that the wastewater is more dirty. So therefore, a higher BOD value usually indicates that the wastewater contains higher amount of biodegradable organic pollutant. There is more pollution is there. Their concentration is more. So this is the BOD. In some of the water, there are no bacteria. Like industrial wastewater contain a lot of chemicals, the acids and others, so the bacteria cannot grow. So you cannot find out the BOD. So what you will do, you will go for another test which is called the COD, and chemical oxygen demand. It is the amount of the oxygen required to determine using a chemical process to oxidize the organic material. In this process, we add some chemical, and how much oxygen used in this chemical reaction will indirectly give us how much is the dirty is the wastewater, how much pollutants are there. The advantage of this method is that it is simple method. Just you have to use the chemical and measure the oxygen consumed, and this test can be done in 1 to 3 hours, while the BOD required around 5 days to complete the test. Consistent results you will get from the same result whenever you do the testing again and again. The disadvantage is that it cannot assess the wastewater biodegradably. Yani it cannot check that how the bacteria can remove the waste material. So this is the only disadvantage. The bacteria are not there, so you cannot check the how much biodegradable. Biodegradable mean the the waste material removed by bacteria. So you can check that, but it is very simple and very quick test. This is used mostly for the industrial wastewater. In the wastewater there are some solids also, with the liquid there are some solids. There are two types of the solid major classification. The total solids is in total dissolved solids, and total suspended solid. Yani if you have a water, when you will filter this water, there will be some solids will be on the filter paper. That is the suspended material you can remove. And there is some solids which are in dissolved form, like if you put the sugar in the water, you mix it, it will dissolve. So there are some dissolved solid, there are some suspended solid, and each of these solids having the two part of the solids: fixed suspended solid and volatile suspended solid. Fixed are those solids which will remain there when you will heat the solids. It will remain there, it will become like black material. Volatile solids are those solids when you will heat it, it will evaporate. So these are the fixed solid and volatile solid. Same thing in the dissolved solid: fixed dissolved solid and volatile dissolved solid. And the summation of these, or for these two fixed solids, are called the total fixed solid. For the summation of the total volatile solids are called the total volatile solids. So these are the different type of the solids present in a wastewater. This is just an example to show you the standards of the wastewater quality. For example, you measure the total solid, total dissolved solid, suspended solid in the lab, all this thing. Then this value, when you will get in the lab, it can give you the idea whether the wastewater is very dirty, very strong, or is a medium dirty, or it is weak, yani little pollution are there. So these parameter, when you check, when you get the value, you can compare with this table. For example, you measured in the lab the chloride. If chloride is around 80 or 83, then it is very dirty water. If it is around 40, then it is medium. If it is around 20, it is a weak wastewater. So based that on that, you can classify. Why we are measuring this thing and finding the quality? Because we want to do the treatment. If it is strong wastewater, we have to use a better method to remove the pollution. If it is weak, then a simple method can be used to remove the waste material. When we do the testing, wastewater testing, and then we go for the treatment, what are our objective, what are the goals? Testing we do to check the quality of the wastewater. Or for what we are checking the quality? For discharge. If we want to throw this wastewater into the river or into the lake, it may damage the river. Water will not be usable for the people, right? So that's why we check the discharge quality. And if we want to reuse, also we check the quality. Also, sometime if we need to design a treatment plant, wastewater treatment plant, then we need to check the what type of wastewater we have to treat. So the treatment method design based on the quality. So we need to check the quality. For also, if there is existing wastewater treatment plant, to see that whether this treatment plant is doing good the work with good efficiency, then we also check the quality of the effluent, the water which is coming to the wastewater treatment plant, and after treatment how much the pollution is there. So this will give the efficiency. In the coming slide, I will also tell you how you can calculate the efficiency of the wastewater treatment plant. Once you check the quality, then you have to think about the method of the treatment. So the treatment objective is that to treat the polluted water to meet the discharge requirement. And for example, when there is a acidic water, when you will treat this wastewater, you have to bring the pH of the water around 6.5 to 8.5. If the wastewater pH is more than 8.5 or less than 6.5, then it is not good for us. So it is the discharge requirement, it is the standard. So based on that, you design your treatment plan. And also to reduce the impact on the receiving wastewater by the removal of this all this pollution. Yani you are doing the treatment, why? To because in the river and the sea, if you will put the dirty water which is having all this pollutant, then it will be damaged. The river and the lake will be damaged. So you have to remove this material. So this is the treatment. What type of treatment you need to use? For example, for removing the pathogen, you can do the disinfection, adding the chlorine or UV light. It can remove the pathogen. So this is the goal of the treatment. These are some of the standards following in the Saudi Arabia, like the Presidency of the Meteorology and Environment in Saudi Arabia. They have the effluent standard. Effluent mean the wastewater after treatment. So the standards for the effluent are given this one. And for example, you did the treatment in the wastewater, then you check the quality in the lab and you check all these things. the BOD, solids, pH, COD, all this. And if it is within this limit, it is okay. If it is more than that, for example, BOD is more than 25, you should not use it. But if you get less than 25, then it is good quality, right? So these are the standards you have to follow to reuse any wastewater. The efficiency of a treatment plant is very important. When the wastewater is coming to a treatment plant, it will go for the primary treatment. As you remember, I shown you in that color picture of the wastewater treatment plant, there are primary treatment, secondary treatment like the biological treatment, and so on. So for example, the water is coming, it is treated up to the primary level, then it will go to the biological aeration, it will treat it more, it will become more clean, and then it will go to the next step, and so on. And here the effluent will be discharged. Effluent means the wastewater after treatment. Influent, the wastewater which is coming to the treatment plant. So generally, the concentration of the pollutants like the BOD, suspended solid, phosphorus, nitrogen are higher as compared to the after treatment. You can see that the here the BOD 200, here it is 30. Here suspended solid 240, it is 30, right? So how I can find out the efficiency of the treatment plant? So the efficiency is simply you can you can calculate the efficiency of any treatment plant can be calculated by the influent concentration. For example, I want to calculate the efficiency of BOD removal in this treatment plant. So BOD, initial BOD is 200, so I will put just 200 here, right? So this 200 minus the final value is 30, minus 30, right, divided by the initial value again 200. So in this way you can find the out how much is the removal efficiency. Generally efficiency is measured in percentage, so what you can do, you can multiply by 100 to get it in percentage. This is the way to calculate the efficiency of any pollutant. For BOD you can do that. So same thing for the suspended solid, 240 minus 30 divided by 240 multiply 100. So in this way you can calculate for BOD, COD, phosphorus, nitrogen, anything. And also you can even calculate the efficiency of the primary settling between these two values. Yani 200 minus 130 divided by 200. Yani between these 2 points, or between the final and this point. So if this initial and final value is given, you can calculate the efficiency of any unit which is doing the treatment, how much is the efficiency of that unit. So this is the method of the calculating the efficiency. Primary wastewater treatment is, as I told you, there are three types of treatment: primary, secondary, and tertiary. In the primary, generally we remove the big solid particles, and that thing, it is called as the Barrick screen. The Barrick screen is it is kind of the bars in a window. When the wastewater is coming, it will pass through that, and then the clean water will pass and the solids will remain there. It could be a moving bar rake, it could be a stationary bar rake, right? So this is the thing. So it will remove the big solids, right? And if the bar rake is not clean, then maybe the solids will choke or clog the bar rake, so you have to clean it periodically. So screen is called as a bar rake also. The position of this bar rake in the treatment plant is before the grit removal. If you remember that figure, it is before the grit removal tank, and just at the beginning of the treatment plant and the beginning of the pumps. Cleaning we do manually or mechanically. You can do by manual cleaning or mechanical treatment you can do, so you can remove the solids from the bar rake. Grit removal is another tank like this one. The water will pass through the tank, and the solids like this one, the sand and other small solid particle can be removed. So this is called the grit: sand, wood pieces, bone, etc. Why we remove the grit? Because if the grit will remain there when the water will go into the pumps, it may damage the pumps, right? And there may be these solids are generally non-biodegradable, and it cannot be removed by the bacteria, so it will remain there. It will not remove from the wastewater. And also it will, when it will go to the piping system, it will choke the pipe, it will block the pipe because of this settling in the pipe. So that's why we do the grit removal. After that it will go to the sedimentation tank or secondary, the settling tank. It is something like that. It could be a circular one, rectangular one. So the wastewater coming, it will be filled here, and we leave for a few hours, so all the solid will settle down. This is a cross section. When the wastewater will come here, the solid will settle and it will can be removed from here, right? So clean water can be taken from the top. So the rectangular tank can be used, circular tank can be used. It depends on the space and the cost. So that is the reason. Otherwise both do the same purpose. Secondary treatment, which is also called as the biological treatment, and this treatment we do to remove and reduce the BOD, dissolved organic material, from that, and by using the bacteria or the microorganism. So there are different methods, like there is very common, very old method which is called the lagoon system. And lagoon system is like a big pond, and the wastewater, when it is coming, it is filled in this tank, and there is air, and air contain the oxygen. It will be dissolved with this one with the time, and the bacteria will remove the waste material, and the water will become clean after some time. So all the microorganisms are there in suspension. There is another method which is called activated sludge system. It is the modification of the system. Generally we use in the cities, and we make big tanks, and the wastewater will go here. We provide the mixing with the fan, and the more oxygen will be dissolved. Bacteria will remove fast the organic material. Again, there are microorganisms like here, and they are in suspension. This is the biological treatment. After that biological treatment, as I told you, the bacteria will remove all the waste material, and bacteria will grow in number and heavier. So those can be removed from the wastewater, again by putting the settling tank. So secondary clarifier or settling tank, here we remove all the biomass. Biomass means bacteria and the waste material. Same thing we will do, we leave for some time, and then it will settle all the waste material, and we can get the cleaner water from the top. So this is the secondary clarifier. If we need more clean water, the wastewater still we want to treat. So the reason of going for the tertiary treatment, it is also called the advanced wastewater treatment, in order to meet the stringent wastewater effluent standard. And in some countries the wastewater standards are very stringent, very tough. You have to treat very good quality, bring to the wastewater to a very good quality to get those standards, and it is not simple to treat. So in some countries we need to do that, so we go for the tertiary treatment after doing the secondary treatment. And also sometime we need to remove more waste material like the solids and the other organic material, because in the next step we have to do the disinfection. So we will use less chlorine and the other material to do the disinfection. We go for further treatment. So in the next treatment, tertiary treatment, we get more clean and very excellent quality of the wastewater. Then you can even use it. So the secondary treated effluent cannot be reused directly. So you have to go for this tertiary treatment for reuse. For example, you want to use the wastewater for growing the potato and tomato, this for growing the food. So you cannot use any wastewater containing some pollutants. So you go for tertiary treatment to get very clean water to use for growing those plants. There are different method, advanced method, which is called the media filtration, activated carbon adsorption, membrane filtration, oxidation processes. They are all these methods are the coming under the tertiary treatment or advanced treatment. When we go for the advanced treatment, the tertiary treatment, our concern also about some of the pollutants which are called as the recalcitrant. Recalcitrant organic pollutants are those which are very difficult to remove from the wastewater by doing the secondary treatment, like the pharmaceutical products, like the medicine producing companies. When they are producing the medicine, there are some compounds which cannot be removed by secondary treatment, so you have to go for tertiary treatment. Sometimes you have to remove the synthetic organic compound, which are also sometimes comes in the water from the industry. And also when we want to remove the pathogens, the bacteria and viruses which can cause disease, then we go for the tertiary treatment like disinfection. If you want to remove the metals, for example lead and mercury, then we go for the tertiary treatment. If there are so much suspended solid, we have to remove that one. If there are nutrients like the phosphorus, nitrogen, so these are the pollutants we want to remove in the tertiary treatment. As I told you, there are different methods in the tertiary treatment. One control method is activated carbon. Activated carbon is a material like this one. It is actually made up of the coal, the faham, like that one, black type of material. And when we put the wastewater here and we mix it for some time, like around 15 minutes something, then when you will remove this solid from here, the carbon, you will see a very clean water. For example, this is the example of removing the color from the wastewater. The wastewater having blue color, when you will add with the carbon after uh, mixing for some time, you will get a very clean water. So this is done by activated carbon. Actually the carbon having the property of attaching the pollutants to their surface. So when the color will go here, the color ions will attach to the carbon and the water will become clean, right? In the filtration method, there are various methods. I will not go in detail. This is the names of the different membrane filtration method I have mentioned here: the reverse osmosis process, nanofiltration, ultrafiltration, and microfiltration. These are the most common processes we use in the tertiary treatment. This is the picture of some of the membranes. These are the membranes like filters, like filter papers. Like you see, this is more fine one. So when the wastewater is coming here and there is a filter, when for example the wastewater contain the salts, the black in color, and the water molecule, the blue in color, when it will pass through the membrane, it will allow only the water to pass, and the solid, the salts, it will remove as a concentrate. So here you will get the permeate, which is the clean water, only the water. So the membrane help us to remove the salts and other pollutants, and you will get the clean water. So this is the reverse osmosis process or the membrane process. Let us see the reuse. When we treat the wastewater, our one of the objective to reuse it again, because this is the most important issue in the region where is the water scarcity and water shortage problem is there. So we can reuse the wastewater, so we will save lot of sweet water. So standard for reusing should be followed. If we want to reuse, we should not use the dirty wastewater directly for growing the plants and any other thing or for industry. So these are the standards given by the Environmental Protection Agency, the EPA. So for example, the pH should be between this value, BUD should be less than 10 milligram per liter, turbidity should be less than 2 NTU, the bacteria, E. coli pathogen should not be there, chlorine should be more than 1 milligram per liter. So these are the standard given by the EPA. EPA guideline is given for various use. So disinfected tertiary treated effluent can be used in many places. So these are the area where we can use. For example, urban reuse. Urban reuse mean we can use for street washing. We can use for washing the channels, or we can use for even the agriculture purposes in the cities. Restricted access area irrigation, yani in some of the cases when wastewater is not very clean, we can use for growing at least for the grass and the greenery, right? Agriculture use, for example, we are using the wastewater for growing the food, potato, tomato, other plants. Recreational impoundment, we can use the wastewater to make the ponds, lake, so people can go and have the picnic over there. Landscape impoundment. Landscape mean the greenery in the area. For example, in the street you see the on the both side the green area, that is the landscaping. Construction use, you can use this wastewater for mixing the cement and the sand to make the concrete. Industrial use, for example, in the heating water, the boiling in the boiler, heat exchanger, you can use this water. Groundwater also you can recharge with this one, and sometime indirectly you can reuse as a potable water, yani for drinking water. Agriculture use of the wastewater having some important issues. The water need for irrigation in some countries is more than 80%. Like in Saudi Arabia, we sometimes use 80 to 90% of the water for agriculture. So there are different regulation in the countries depending on the countries to reuse the wastewater after level of the treatment. If you get this level of the treatment, you can reuse for agriculture purposes. What are the benefit of using in the agriculture? Because the wastewater which you will use for growing the plant already having the nutrients. You don't need the fertilizer. There is nitrogen, phosphorus already in the wastewater, so it will eliminate the need of the fertilizer. Right? It will decrease the demand on the potable water you supply, and sweet water you will save. You can save the waste, the supply of the clean water, sweet water, by using this wastewater. And you don't have to throw this wastewater into the water, so you will reduce the environmental pollution also. Disadvantage: there are few things we should consider when we are using the wastewater. There are could be health risk. If there are pathogens which are present in the wastewater, you are using that wastewater, then there is a health risk. And also due to the health risk because of metals and chemicals. And also if you use this wastewater continuously in the soil and the water is acidic, then it will maybe damage the soil quality also. If this wastewater go to the groundwater, it may cause the damage to the groundwater quality. So these are the disadvantages, and the previous are the these are the advantages. So we have to use the wastewater wisely. It should not be used improperly, so it can cause the harm to environment. In the cities, urban areas, we can use for many purposes like the irrigation for growing the greenery area, public parks, school, road, medians, landscaping, golf courses. In the commercial area like the washing of the cars, laundries, window washing, mixing pesticides, herbicide. In the construction also you can use the for concrete production, flushing of the toilets, fire protection, right? Even in some of the area, like in Australia, they are using this very good quality of the treated wastewater as a drinking water. But not in many countries this is being used. The wastewater use system, if it is there in like in some of the developed countries, they have the both piping system, the fresh water and the wastewater, which are they are reusing. So there is a dual distribution system. So the water is coming in two pipes, two different pipeline system. One is bringing the municipal water, clean water, and one other having the wastewater. So network of the pipe is delivered to reclaim to the public, right? And generally these two type of the pipelines are going in parallel, like sweet water, potable water, and the wastewater going in parallel. The potential problem in this kind of the system is that if some plumber or something is doing the repair of this piping system, he doesn't know about that, so there may be cross connection. He will connect the wastewater line with the sweet water line, and it is not good for the public health and environment. So this is one of the problem in the wastewater use system. Residential also, in the houses we can reuse the wastewater, and we can save lot of the drinking water, clean water during the drought. If there is shortage of the water in those countries where the climate is very hot, we can reuse this wastewater to decrease the load of the water supply on the high population area, right? And you will save a lot of money for purchasing the sweet water. So it will reduce the environmental impact which are associated with the wastewater treatment and disposal. So wastewater reuse is very good advantage for us. Residential wastewater equipments are there which are treating the wastewater within the houses, and you can reuse it again, like you can reuse the wastewater again in the this flushing of the commode, right? There are equipment in which the wastewater coming from here, it will be treated, and from the bottom the clean water wastewater will can go again to the system. So this is the residential wastewater treatment system. So as a conclusion, just briefly, the many current use of the recycled wastewater is there. You can use in many ways the wastewater, but after good treatment. So the varying level of the treatment is required. You have to treat the primary treatment up to the primary treatment, secondary treatment, or tertiary treatment. The advantages, pros mean advantages. It will conserve the potable water. It will save a lot of sweet water. It will reduce the effluent to the environment. You will not discharge a lot of wastewater into the river and the sea. And the cons are there. There are some disadvantages also. Health and safety precaution is necessary. If you will use some wastewater which is having like pathogen, then it can cause disease. If it has some metals, it can cause disease. So you have to provide the planning carefully, otherwise you cannot do that. So good planning is needed in the wastewater use. So there is, but the thing is that in the present timing we can see that there is a big potential for reuse of the wastewater in the future. So people will go ultimately for reusing the wastewater, because with the time the water will become short and the population will increase. So this is the all about the today's lecture about the wastewater testing, quality check, and the reuse. This is very important, and it is one of the major issue in the all over the world, not only for Saudi Arabia or the Gulf countries. Everywhere this problem is there. So in some countries it is more, and some countries it is not much. So this is just go over that. If you face any problem, just contact me on the Blackboard. I will explain you again.